Hello and welcome to the continuation of answering every question in the textbook. This is part 9 where we are starting at topic 46. For those of you that are just joining, in this collection of videos what I'm doing is I'm working through every question in the textbook that I've made recently, just to do one last check before it is actually going to be printed. So this is the book here. It's Functional Skills Maths Level 2, everything you need to know. And it's meant to be fast, clear and stress-free practice for all adult learners or anyone studying Functional Skills Maths Level 2. The textbook is filled with all of the questions that are on the website. I know that from my own students, they like to have these things printed out. So the purpose of this is just to have these things here, but printed out and resized for you in a way that is appropriate and just there for you to work through and get general practice. What you'll notice is on each of the pages, one second, let me just go to the main screen. On each of the pages there is also a QR code here, and each one of these QR codes will take you directly to the lesson that tells you how to do what is on. Okay, so there we go. So without any further discussion or need for anything else, we can get started with this. So let's have a look at this. We're on topic 46, which is calculate the perimeter of compound shapes. And this says practice questions, round answers up to 2 decimal places, use pi equals 3.14. Okay, so let's begin. Question 1, a shape is made of a rectangle with length 8 centimeters and width 6 centimeters. Okay, we can see that here. On each side of the 6 centimeter sides, there is a semicircle. What is the total perimeter of the shape? So the total perimeter of the shape is the distance all the way round the shape. So it's going to be 8 add 8 for the 2 straight bits. And then for the curvy bits, we've got 2 semicircles there. So 2 semicircles makes up a circle. The diameter is 6 centimeters. And you might remember that circumference of a circle, so that's the distance around the outside, circumference equals pi times diameter, which in this case is going to be 3.14 times 6, and then we can work out what that is and add it to our 8 add 8. Okay, so let's get started. So here we go, 8 add 8. Oh no, let's do the 3.14 times 6 first. 3.14 times 6, and that equals 18.84. And then if we do 8 add 8 add 18.84, we will get the final answer, which will be the total perimeter of this shape. So we've got here 8 add 8 add 18.84. And that's going to equal 34.84, and it's centimeters because perimeter is still a length. Okay, next one. Oh, I went over to the side. There you go. A shape is made of a rectangle with length 12 millimeters and width 9 millimeters. Yeah, I can see that. On each end there is a semicircle. What is the total perimeter of the shape? So it's the same business again. We've got the 12, add the 12, and then we've got to add on the pi times diameter, which will give us the full circle, which makes made by the 2 semicircles. So 3.14 times 9, we'll work that out here. 3.14 times 9 is 28.26. So we've got 12 add 12 add 28.26, and then we can find out what that is here. So 28.26 add 24, which is the 12 add 12. So that's going to be 52.26. Oh, and it's millimeters this time. Okay, there we go. Let's just write that again. Oh no, I deleted part of the 6. Oh my gosh, millimeters. Right, here we go. Okay, right. Next topic, question 3. This one's a little bit trickier. A shape is made of a rectangle with length 6 meters and width 4 meters. On the 6th is made with On the 6 meter side to the right of the rectangle, there is a rectangle with a length of 5 meters and a width 3 meters. What is the total perimeter of the shape? I don't actually like how that reads. A shape is made of a rectangle with length 6 meters and width 3 meters. On the 6 meter side, because it's made of 2 rectangles, isn't it? That's what it's made of. So 1 second. So let's just get rid of that one. And then here we go. A shape is made of 2 rectangles. One with length and I think I don't need all this bit onto the right because it's obvious from the picture. On the 6 centimeter side to the right of the and here we go. And another with, here we go, that's much better. A shape is made of 2 rectangles, one with length 6 meters and width 4 meters, and another with length 5 meters and width 3 meters. What is the total perimeter of the shape? Okay, so here we go. So it's all the same though. So here we can work this out. So we know that this is 4, this is 6, this is 3. Oh, okay, so we've got some bits that we don't know. Right, so if this from here to here is 6, but here to here is 3, that means that here to here will also be 3. So that will also be 3 meters there. And then if from here to here is 4, and then from here to here is 5, this whole length here will be 4 add 5, which will be 9 meters, okay? So if we start here, we've got 4 meters, 4 add 6, add 9, add 3, add 5, and then add this 3 as well here. So that's, let's just check, 1, 2, 3, 4, 5, 6 sides, 1, 2, 3, 4, 5, 6 measurements there, and I can just add these up. So 4 add 6 is 10, 19, 22, 27, 30 meters. Okay, right. Let's have a look at question 4. So question 4 says a shape is made with length. A shape is made of a rectangle with length 10 centimeters and width 8 centimeters. On one of the 8 centimeter sides there is a semicircle. What is the total perimeter of the shape? Okay, so here we go. I think that's fine with this one. It doesn't read as badly as that other one did. So we've got here 8 and 10. So this is 8, this is 10, and then this is 10 as well. We know that this is 8. So what we've got to do is we've got to work out this bit here. So that would be the circumference of the circle, but because it's a semicircle, it's just half of that. So if it was the whole circle, it'd be 3.14 times 8, because it's pi times diameter. But because it's a semicircle, we have to divide this by 2. So let's work that out here. 3.14 times 8 equals 25. Then divide that by 2. Here you go, it's 12.56 centimeters. And then we can add those together. So we've got 10, add 10, add 8, add 12.56. And let's work out what that gives us. So that's plus 10, plus 10, plus 8. And there we go. So the answer to that will be 40.56 centimeters. So I'm just going to read through this once more. A shape is made of a rectangle with length 10 centimeters and width 8 centimeters. On one of the 8 centimeter sides, there is a semicircle. What is the perimeter? Yeah, that's fine. Okay, question 5. A shape is made of a rectangle with length 14 millimeters and width 4 millimeters. On the top there is an isosceles triangle with a base of 14 millimeters and side lengths 10 millimeters. What is the total perimeter of the shape? I still don't like that. A shape is made of a rectangle and a triangle. Here we go. A shape is made of a rectangle and a triangle. The rectangle has length 14 millimeters and width 4 millimeters. On top there is an isosceles triangle. On top there is an isosceles triangle with a base of 14 millimeters and side lengths and side lengths 10 millimeters. What is the perimeter of the shape? The triangle is isosceles The triangle is isosceles with a base of 14 millimeters and a side length of 10 millimeters. What is the total perimeter of the shape? Okay, right. So here we go. That's been edited as well. So here we go. So it's going to be quite straightforward actually. 4 for this side, add 14 for this side, add 4 for this side, add 10 for the two sides. Yeah, that's right. The base of the triangle is actually somewhat irrelevant. So here we go. We've got 4 add 14 is 18. Add another 4 is 22. 32, 42. 42 millimeters. Right, okay, that is that one. So let's get the answers up so we can get this marked. Okay, let's minimize that. Here we go. So this is 45, question 5. Okay, and we'll do the first 5 answers. Okay, so let's turn this here. Right, so 46, question 1 is, 34, 84. Excellent. And then question 2, we've got 52.26. That agrees as well. Question 3, we've got 30. That agrees also. Question 4, we've got 40.56. And then question 5, we've got 42 millimeters. Perfect. So all of the answers are correct there. So we can continue on with the second round of 5. Okay, right, so here we go. Question 6 says, a shape is made of a rectangle with length 9 meters and 4 meters Okay, on one of the 5mm sides there is a semicircle. What is the total perimeter of the shape? Okay, so let's just alter that because that's there. That should be like this. A shape is made of a rectangle and a semicircle. The rectangle has length 9 meters and width and the semicircle sits perfectly on one of the 5-meter sides. Okay, right. A shape is made of a rectangle and a semicircle. The rectangle has length 9 meters and width 5 meters. The semicircle sits perfectly on one of the side. On one. Oh, 1 second. That says 6. 5-meter sides. The semicircle sits perfectly on one of the 5-meter sides. What is the total perimeter of the shape? Okay, so let's go back to the remarkable and get this answered. So here we go. So that should have been 5. That's been changed though. Right, so we've got this would be 12. Remember the diameter of this is 5. Okay, and what we have here is we know that the circumference of a circle is pi times diameter, but this is a semicircle, so we'll have to divide that into 2. So we're going to do 3.14 times 5 divided by 2 to get the length of the curve. So here we go. We're going to do 3.14 times 5 divided by 2, and this will equal 7.85 meters. Okay. So now we can add that to the rest. We've got 12, add 12, add 5, add 7.85. And let's see what this gives us. 12 add 12 is 24, add 5 is 29. So we're just going to add 29 to this. Here we go. So this will be 36.85. And that is meters because perimeter is still a length. Okay, right. Question 7. Okay, a shape is made of an isosceles triangle with lengths 10 meters, 10 centimeters, 10 centimeters, and 3 centimeters. On the 3 centimeter side, there is a semicircle. What is the total perimeter of this shape? Okay, so here we go, and this is going to be, well, it's going to be 10, add the perimeter of the semicircle. So we're going to do pi times diameter, so that's going to be 3.14 times 3, and then it's only half of it because it's a semicircle, so we'll then divide that by 2. So let's work out what this will be. 3.14 times 3 equals this. Divide that by 2, and that is going to be 4.71. So it's going to be 10 add 4.71. So the total perimeter will be 24.71, and it's centimeters because that's what the units are here. Right. A shape is made of a rectangle with length 13 meters and width 9 meters. On one of the 13 meter sides, there is an isosceles triangle with base 8 meters and sides 5 meters. Okay. What is the total perimeter of the shape? Well, if this is an isosceles triangle, it means that is 5 as well. Okay. If this distance from here to here is 8, that means the distance from here to here must be 5, because 8 add 5 gets us to 13, which is the full distance across. If that distance is 9 and this is a rectangle, that distance will be 9 as well. Let's put in my units here. So to get the perimeter of this shape, we're going to do 5, add 5, add 5, 5, add 5, add 5, add 9, add 13, and then add 9 here as well. And we just need to work out what all of that is. So 5 add 5 is 10, 15, 24, 34, 37, 37, 46. So that would be 46 meters here. Right, question 9. A shape is made of a rectangle with length 16 centimeters and width 11 centimeters. So that's this bottom one here. On one of the 16 centimeter side, there is another rectangle, okay, with length 10 centimeters and width 3 centimeters. Yep. What is the total perimeter of this shape? So let's fill out these blank bits. So that's 10. This will be 3 centimeters. This will be 11 centimeters. We don't actually necessarily know what these two bits are here, but we do know that collectively, if from here to here is 10 and here to here is 16, this would have to, they collectively would have to equal 6, because that's how much they'd need to make that length the same. So then we can just add these together. So from the top we've got 10, add 3, and then add this 6 here, add 11, and then add the 16. Okay, and then I can do this all on the calculator. If I'm 10, add 3, add 6, add 11, add 16. Okay, and that makes 60. So that would be 60 centimeters there. Okay, and finally question 10. Here we go. A shape is made of a rectangle with 7 meters, with length 7 meters and width 5 meters. On one of the 5 meter sides, I just need to re-edit that. So here we go. I actually changed my mind about the wording of these, which is a shame. On one of the 5 meter sides, there is a rectangle. On one of the 5 meter sides, there is a rectangle, a right angle triangle with sides 3, 4, 5. So they put them all on there. The shapes are joined along the triangle. The shapes are joined along the triangle's 3 meter edge. Yeah, I can see that. What is the total perimeter of the shape? So we've actually got all of the measurements here. That will be 7 meters at the top because it's a rectangle. We don't need this one here. That's irrelevant to the outside journey. So starting with the 7, we'll have 7 plus 5 plus 4. Oh, 1 second. We haven't worked out this one here. We did need that piece of information. Okay. If from here to here is 3 and the whole length is 5, that means this bit will be 2, because 3 add 2 makes 5. So we've done the 4, so now we can forget about the 3. Then we've got to add the 2, add the 7, add the 5, and this will take us up to back to the 7. So 7 add 5 is 12, add 2 is 16, 18, 25, 30. So this should equal 30 meters. Right, let's get this marked. Okay, so back to question 6. Here we go. Right. So there we go. And get the mark scheme up. Minimize this. So question 6. Oh, we have got 30.85. And I've got 36.85. That's very similar. Let's just check. So pi times diameter divided by 2. Yep, that's right. Oh, I see. It's this old chestnut. It says 9 here in the question, but on the diagram it says 12. Okay, so we need to change that on the diagram to 9. Okay, right. Let me just change that here. So that's what threw us off. 9. Okay. So let's go back to the answers. And let's re-answer this question as if that was a 9. So we're just going to do, it's just this bit that changes. So we'd have 9, add 5. Okay. And let's see if that's correct. So here we go. 9, add 5, add 7.85. And that is 30.85. Okay, and that is meters. Okay, and is that what we've got here? 30.85 meters. Right, let's have a look at the next one. Okay, question 7. So here we go. It says 24.71. Yep, and we agree this time. So that is all good. Question 8 is 46. Yep, that agrees. Question 9 is 60. That agrees. And question 10 is 30. And that agrees as well. So we're pretty happy with that. Okay, right. Let's have a look at these scenario questions. Okay, so a garden consists of a square with side length 4 meters. Okay, square is special because that means all of the side lengths of that square are 4 meters. Okay, a garden consists of a square with side length 4 meters and a semicircle with diameters, and with a semicircle with, and I think we need to rephrase that, and that says, and 4 semicircles. Okay, with a, and 4, and 4 semicircles with diameters of 4 meters attached to of its sides, attached to each of its 4 sides. I think that's obvious now. A garden consists of a square with side length 4 meters and 4 semicircles with diameters of 4 meters attached to each of its sides. Find the total perimeter of the garden. Okay, right, here we go. 4 to each of its 4 sides. Okay, so here we've actually just got 2 circles with diameter 4 meters. So we just need to find the circumference of one of these circles and then double it. So that's going to be 3.14 times 4. Okay, and then we'll find out what that is, and then we will times that by 2. Okay, what's that? Here we go. So let's do this here. So 3.14 times 4 equals 12.56. So that would be so that would be like from here to here, and then we need to double that. 12.56 times 2, and we'll see what we get there. So 12.56 times 2 will equal 25.12 meters. Okay, great. Question 2. A bathroom floor is in the shape of a rectangle with dimensions 6 feet by 8 feet. And there is a okay, that's a new sentence. There is a semicircular bathtub with a radius of 3 feet cut out. Yeah, okay. Oh dear. This is what happens when maths teachers construct long sentences. Right. Okay. Here we go. Right, a bathroom floor is in the shape of a rectangle with dimensions 6 feet by 8 feet. There is a semicircular bathtub with a radius of 3 feet cut out of one of the 6 foot sides. Calculate the total perimeter of the bathroom floor. Okay, a bathroom floor is in the shape of a rectangle with dimensions 6 feet by 8 feet. There is a semicircular bathtub with a radius of 3 feet cut out of one of the 6-foot sides. Calculate the total perimeter of the bathroom floor. Okay, so there we go. Okay, so let's work this out. So this is 8, that's 6. And we've got to work out this. So it's a semicircle. So the circumference of a semicircle again is 3.14 times the diameter, and then divide that by 2. Okay, and we can do this all in one go. So 3.14 times 6 equals this, and then divide that by 2 is 9.42. So that'll be, this bit here will be 9.42. Then we can add all those up. So we've got 8, add 6, add 9.42. And this is what this is going to equal. 8 add 8 is 16, add 6 is 22. So this add 22 will be 31.42 feet. Okay, right, next. Question 3. An amusement park ride follows a track made by an isosceles triangle with side lengths 6 meters, 6 meters, and 7 meters, and a rectangle with sides measuring 4 by 8 meters. Determine the total perimeter of the ride. Okay, well, this is quite straightforward because it looks here they just touch there. So it's going to go all the way around this rectangle. I don't know how it does it. That'll be 8m and that'll be 4m. And then this is an isosceles triangle, and they've said it's 2 6-meter sides. So this side here must be 6 meters. So let's just add all of these numbers together. So we've got 8, add 8, add 4, add 4, add 6, add 6, add 7. And this will be the total length of the track. So 8 add 8 is 16, add 4 is 20, 24, add the 6 makes us 30, 36, 43. So this should be 43 meters here. Right, question 4. A swimming pool has a rectangular shape with dimensions 10 feet by 20 feet. Inside the pool, there is a circular spa with a radius of 4 feet. Find the total perimeter of the pool and spa complex. Okay, right, so that's 10 feet, that's 10 feet. This is 20 feet. This would also have to be 20 feet because it's a rectangle, so opposite sides are the same. Now, if this is 4 feet as the radius, that means from here to here is 8 feet. Now, if all the way across is 10 feet, that means that this little bit here is 2 feet. And then I just need to work out the circumference of the circle and divide it by 2. So circumference of a circle is 3.14 times the diameter. The diameter is 8. And then because it's a semicircle, we just divide it by 2. Okay, so we can just do this. 3.14 times 8 equals this. Divide that by 2. Gives us 12.56. Okay, that's feet. So then what we just do is we just add everything together. 20, add 20, add 10, add 12.56. And then we see what that gets us. So 20 add 20 add 10 is 50. So I just need to add 50 onto this here. And that's going to be 62.56. And that's going to be feet. Okay, right, question 5. Here we go. A playground has a square area with sides measuring 12 meters. Yeah. Right, 1 second. Right. There is a quarter circle sandbox with radius of 3 meters located in one corner of the square. Calculate the perimeter cut out of one corner of the square. A playground has a square area with sides measuring 12 metres. There is a quarter circle sandbox with a radius of 3 metres cut out of one corner of the square. Calculate the total perimeter of the playground. So here we go. Fine, let's complete that. So what we have is we've got, this is 12, this is 12. Now, if the radius is 3, that means these sides are going to be 9 and 9. Okay, and then we just need to calculate what this bit is here. So this is a quarter circle. So if it's got a radius of 3, we can use the radius formula for the circumference. So that's going to be 2 times 3 times 3.14. Okay, but then, so that gives us a circumference if we had the whole circle with a radius of 3. But we've only got a quarter of a circle this time, so we're going to divide this answer by 4, and that will tell us what that little bit is there. So 2 times 3 times 3.14 equals this, and then divide that by 4, gives us 4.71. So our total perimeter of this shape is going to be 12, add 12, add 9, add 9, add 4.71. And so 12 add 12 is 24, 9 add 9 is 18, 19 add 24 is 42, so this will be 46.71 meters. Okay, right. Let's try question 6. Let's get these marked. That's what we were going to do. That's the next plan. We've done 1 to 5. So let's get these marked. So here we go. So, right. 25.12. Brilliant. The wording might not be right, but the answers are matching up, so that's good. 31.42 is good as well. 43 matches too. And 64.56 matches as well. 46.71 matches. And here we go, we're on to question 6. Okay, so let's enlarge this and keep going with question 6. Okay, so a park consists of a rectangular field measuring 14 yards by 20 yards. Within the field there is a semicircular pond with a radius of 5 yards. Okay, determine the total perimeter of the park. Okay, so if that's 20, that's 14. This will be 14 as well. If this has a radius of 5, that means all the way across is 10. So we don't know if this is a complete symmetrical way, but we do know that these two bits here will equal 10 collectively. Okay, and then we just need to work out the perimeter of the semicircle. So it's going to be 3.14 times the diameter, which would be 10, and then divide that by 2 because we only want the semicircle. So here we're going to go with this. So we've got 3.14 times 10 equals this, and then divide that by 2. Here we go. So the curvy bit is going to be 15.7 yards. So then we can just add everything up together. So we've got 14, add 10, add 15.7, add 14, add 20. Well, 20 add 10 is 30. 14 add 14 is 28. So we're up to 58. 58 add, let's just add this on here. Add 58. So that's going to equal 73.7 yards. Okay, right. Next one. Question 7. A hiking trail has a rectangular segment measuring 8 kilometers by 4 kilometers. And there is a... It doesn't read well. A hiking trail has a rectangular segment measuring 8 kilometers by 4 kilometers, and there is a triangular section with a base of 6 kilometers and sides of 5 kilometers. Right, that doesn't read well, I'm afraid. Sorry about this. This is not the best one, but this is why we do this, okay? Okay, a hiking trail has a rectangular segment measuring 8 kilometers by 4 kilometers. There is a triangular section with a base of 6 kilometers and 2 sides of 5 kilometers. Attached to the 8 kilometer side. Find the total perimeter of the trail. Oh gosh. Right. Okay, right. A hiking trail has a rectangular segment measuring 8 kilometers by 4 kilometers. There is a triangular section with a base of 6 kilometers and 2 sides of 5 kilometers attached to the 8 kilometer side. Find the total perimeter of the trail. Okay, so let's answer this now. Okay, so that's 5 kilometers as well, because there's 2 sides of 5 kilometers and the base is that. If from here to here is 6 kilometers and here to here is 8 kilometers, that means that this bit is 2 kilometers. And as this is a rectangle, this opposite side will be 4 kilometers. Okay, so what we need to do is we now need to add all of these up together. So we've got 5, add 2, add 4, add 8, add 4. Okay, so we've got 10, 12, 20, 24, 28. So that's going to be 28 kilometers. Okay, right. Question 8. A football field, one second, there's an unnecessary gap. A football field has a rectangular shape measuring 90 meters by 120 meters with a semicircular arc at each end of the field. And that works that time. Each arc has a radius of 45 meters. Calculate the total perimeter of the football field. Okay, great. So here we go. Though that diagram, that dotted line is too long. So let's just quickly fix that. There we go. Right. Okay, right. Done. So here we go. Right, so we're going to have 120, add 120, and then we've got 2 semicircles this time. So together they make a whole circle. The diameter of this whole circle would be 90. So what we're going to do is we are going to do 3.14 times 90 and find out what that equals. So here we go. We've got 3.14 times 90, and here we go, that equals 282. Okay, so we're going to add that on here, 282, because that gives us the distance of the curves. So then let's do 282, and then let's add 240, because that's 120 out of 120. So altogether this would be 522.6 meters. Okay, here we go. Right, next bit. Question 9. A building rooftop has a square shape measuring 15 feet on each side. Okay, again, I don't know why I was using this comma. That doesn't work. It needs to be that needs to be a new sentence. Or maybe it just needs to not have the comma. A building rooftop has a square shape measuring 15 feet on each side with a right angle triangle with a right angle triangle with sides 3 feet, 4 feet and 5 feet cut out from one corner. Yeah, that's right. Okay, determine the total perimeter of the rooftop area. Okay, so let's go back and let's work this out. So here we go. A building rooftop has a square shape with 15 feet on each side. No, it does need, sorry, I keep changing my mind. On each side. There is a right angled triangle A building rooftop has a square shape measuring 15 feet on each side. There is a triangle area. There is a right angle triangle. There is a right angle triangle with sides 3 feet, 4 feet and 5 feet cut out from one corner. Determine the total perimeter of the rooftop area. Okay, fine. I'm happy with that now. So let's work this out. So it was a full stop and that was there. Okay, so that's 15, that's 15. If this is 4 feet, that means that this bit will be 11 feet. If this bit is 15 feet and this is 3 feet, this bit will be 12 feet. So the perimeter is going to be 15, add 15, add the 11, add the 5, add the 12. Okay, so 15 add 15 is 30, add 11 is 41, add the 5 takes us to 46, and add the 12 takes us to 58 feet. Okay, and lastly for this section, question 10, and we've got here, a shopping complex has a rectangular building measuring 40 metres by 60 metres. There is also a triangular courtyard which runs the full length of the 60 metre side, with the other two sides at 50 metres each. Right. Okay, find the perimeter of the shopping complex. A shopping complex is a rectangular building. That's a floor plan. Has a rectangular floor plan measuring 40 metres by 60 metres. There is a triangle. There is also. It also has. It also has a triangular courtyard which runs the full length of the 60 metre side. Of the 60 metre side, where the other two sides of the triangle are 50 metres each. Right, sorry about this. 50 metres each. Find the perimeter of the shopping complex. Okay, right, so here we go. I feel like with these ones, the writing is harder than the question. So anyway, right. So we've got here 50 metres, this was 40 metres, 60 metres, 40 metres, and that's 50 metres as well. So we've got 50, add 50, add 40, add 60, add 40. Okay, so 50 and 50 make 100, 40 and 60 make 100, so this will equal 240 metres. Okay, right. Let's have a look at the mark scheme, and then that will be that for compound perimeter. So let's get that done. So here we go. Right, so question 6. We need that mark scheme. Right, so here we go. Question 6 for this one is 73.7 yards. Yep, that agrees. 28 kilometers. Yep, that agrees as well. 50. Oh, I forgot to do the second bit. Question 8 is 522.6. Yep, that agrees. And then question 9 is 58 feet. And question 10 is 240 meters. Perfect. Right, okay. Let's have a go at question 47. Okay, so this one is topic 47. What is this all about? It's use formulas to calculate the volume of 3D shapes. Okay, right, so here we go. We've got find the volume of a rectangular prism with length 6 centimeters, width equal to 4 centimeters, and height equal to 5 centimeters. It says here that the volume of a cuboid, okay, equals length times width times height. Okay, right, so I don't like the fact that I've called it's a rectangular prism here, and then we've given the volume for the formula of a cuboid. They are both the same things, but I think for one question I should use the same word throughout. Okay, and here we go. So volume equal, yeah, I think that's fine with the V. Right, that needs to change there though. So that needs to be like that. Oh no. Oh no! Ah, damn it. Right, Control Z, Z, Z. Right, so I want this bit. Ah, that's perfect. Yeah, here we go. So find the volume of a cuboid with length 6. Volume of a cuboid is given by... I don't need that V there, to be honest. If that's like that. Okay. But maybe I could... no, I think that's fine like that. Okay. Volume of a cuboid is length times width times height. Okay. Right. Or maybe it should be... Right, why have I done it like that? 1 second. There must be a stylistic thing. Okay, I've done it throughout the whole thing. I'm going to actually keep that as it was. It doesn't throw anything off. Okay. Right. Oh. Okay, right. Right, here we've got here. Right, sorry about this. Right, so what we've got here, we have got, so volume is length times width times height. So we've got 6 times, go back to black, 6 times 4 times 5. Okay, 6 times 4, well, 4 times 5 is 20, 6 times 20 is 120, and that would be centimetres cubed. Okay. Question 2, we've got here, the volume of a cone with radius 3. Volume of a cone equals 1/3 times pi times radius squared times height. So that's going to be 1/3 times 3.14 times height squared, which will be 7 squared, no, times radius squared, which will be 3 squared, which will be times 3 times 3, and then times 7. Okay, so here we go. I think I'm going to use the calculator for this. So remember, if you want to do 1/3, we just do 1 divided by 3 and press equals, and then we've got our third in our calculator. Then we can times the rest by here. 3.14 times 3.14 times 3. Oh no, I only want that once. Times 3 times 3 times 7. Okay, so that's going to be 65.94 centimeters cubed. Okay. Question 3. Calculate the volume of a cylinder with radius 2.5 meters and height 10 meters. So the volume of a cylinder is V equals the pi times radius squared times height. So what we've got here is we've got 3.14 times radius squared, so that's 2.5 times 2.5, and then times the height. Okay, and again, I can just put all of this into the calculator here, and we will have 3.14 times 2.5 times 2.5 times 10. Okay, so that's going to be 196.25, and that's going to be meters cubed this time because the units was meters. Okay, right, question 4. Determine the volume of a sphere with radius 8 centimeters. So volume of a sphere is 4/3 times pi times radius cubed. So what that means, we're going to do, we got 4/3 times 3.14 times 8 times 8 times 8. Okay, so let's work this out. Remember, you can do the fraction first. 4 divided by 3, so this is what 4/3 is as a decimal, and then we times that by 3.14 times 8 times 8 times 8. Here we go. So that's going to equal 2143 point. And have we got some direction of how many decimal places? Round answers to the nearest whole number. Oh, I haven't been doing that throughout. So this one would be 196 meters cubed. Okay, so let's get rid of that. And then this one would be 2143.57, but to the nearest whole number, that's 2144 meters cubed. I just need to go back and see if I did that on the last ones. That was a whole number, naturally. And this needs to be rounded to a whole number. So let me get rid of that. Okay, so that's going to be 66 to the nearest whole. Okay, right, we've done that page now. Yay, we're in pages 200. Okay, right, and then we've got question 5 here. So, find the volume of a triangular prism with triangle area 10 centimeters and height 12 centimeters. If the volume of the triangular prism is given by V equals the triangular area times the height. Okay, so we've got V equals the triangular area, which is 10, times the height, which they've told us is 12. Okay, so there we go. 10 times 12 is 120 centimeters cubed. Right, so let's mark these first 5. Okay, here we go. Right, so let's get these first 5 marked. So first one, for this one, here we go. 47, 120 centimeters cubed. The next one is 66 centimeters cubed. Yep. Ooh. This one here is 196 meters cubed. Yep. And then 2,144 meters cubed for question 4. And 120 centimeters cubed for question 5. Okay, right. Let's continue on with the next round. And here we go, we've got question 6. Okay, so here we go. This is going to be calculate the volume of a cube with side length 9 centimeters. So the volume of the cube is given by V equals side length cubed. Okay, so that just means 9 times 9 times 9. Okay, and we can do that on the calculator. 9 times 9 is 81, so then we can just do 81 times 9. And that equals 729 centimeters cubed. Okay. Question 7. Here we are. determine the volume of a pyramid with the base area of 15 meters squared and the height of 6 meters. Okay, so we've got here a third times base area times height. So we've got a third times 15 times 6. Okay, so remember we can do a third by just doing 1 divided by 3. Okay, find out what that equals and then times the 15 and then times the 6. Okay, you might have also known that a third of 15 was 5, so you could have done 5 times 6 as well to get it that way. But either way is fine. Most of these questions you will have a calculator for. There's only a few at the start that you don't. Right, okay. Question 8. Find the volume of a hemisphere with radius 5 millimeters. So here we go. The volume of the hemisphere is given by 2 over 3 times 3.14 times the radius cubed. So that's 5 times 5 times 5. Okay, and we can work out what this is. Okay, so 2 over 3 is 2 divided by 3. Okay, press equals there to get that stored, and then we can times that by the 3.14 times 5 times 5 times 5. Here we go, and that's going to give us 261.67, but actually this is all to nearest whole number, isn't it? So that's going to be 262. Okay, and that is going to be millimeters cubed. Okay, just check. I haven't dropped anything. Yeah, there we go. Right, question 9. Okay, here we go. So question 9 is find the volume of a cuboid. Find the length of a cube. Oh, okay, this is interesting. Find the length of a cuboid with volume 100 centimeters cubed, width 4 centimeters, and height 5 centimeters. Volume of the cuboid equals length times width times height. So we don't have the length. So we know that length times width times height equals 100. Okay, so 4 times 5 is 20. So length times 20 equals 100. So we've got to think what times 20 equals 100. So we just do 100 divided by 20. That will give us 5. So the length will equal 5 centimeters. Okay. Right, question 10. Find the width of the cuboid with volume 300, length 15 and height 10. Okay, so this time we have got the width. We've got 15 times the width times the height is equal to 300. Now remember, it doesn't matter what way we multiply these round, so we can think about this as W times 15 times 10, which is W times 150 equals 300. And you might spot this already, that we know that 2 times 150 equals 300. So the width will equal 2 centimeters, okay? Because 2 times 150 gets us 300. Right, okay, let's mark these. Okay, question 6. There we go. 729 centimeters cubed, perfect. 30 centimeters. Oh, this is cubic meters. Oops. You've got to be careful with these things. Okay. And then here we go. We've got this one here. 262 cubic millimeters, millimeters cubed. Yep. Question 9, we've got 5 centimeters. Excellent. And question 10, we've got 2 centimeters. Right. Okay. This is going well. I mean, there's been a few vocabulary things, but it's good to recheck these, and it's good actually to read these out loud. So this is really helpful. So thank you for all of you that are joining in. Right. Next one we have got 47 scenario. Oh no, the scenarios. Right, they're such long stories, this one's. Okay, right. So, here we go. Fiona wants to fill her rectangular fish tank with water. The tank has... It's not a rectangle. Is it a rectangular fish tank? I guess it is, sort of. It's cuboid. Okay. But I guess the tank element implies that it's cuboid. Okay. Fiona wants to fill her rectangular fish tank with water. If the tank has a length of 60, a width of 40, and a height of 30 centimetres, what is the volume of water that can fit in the tank? I guess... Fiona wants to fill a rectangular fish tank. I think I'll just get rid of the word rectangular because it's obvious the shape of the it's obvious the shape of it. But rectangle, I don't want people to think that that's... Here we go. If the tank is a cuboid, the tank is a cuboid and has... Here we go. Fiona wants to fill her fish tank with water. The tank is a cuboid and has a length of 60 centimetres, a width of 40 centimetres and a height of 30 centimetres. What is the volume of water that can fit in the tank? That is better because we're distinguishing between cuboids and rectangles. So this is fine. I'm happy with that now. Okay, so here we go. We've got the measurements here. So the length is 60 times the width, that is 40, times the height, that is 30. So 40 times 60 times 30. Well, 4 times 3 is 12. 12 times 6 is 72. And then if I add on the 3 zeros, here we go. So that will be 72,000 cubic centimetres cubed, and which interestingly is 72 litres. I don't expect anyone to have done that, but that is what it is, just out of interest. Here we go. An ice cream shop sells ice cream cones. If the cone has a radius of 5 centimetres and a height of 12 centimetres, what is the volume of ice cream that can fit in the cone? Okay, this works. So we're going to have a third times 3.14 times the radius squared, so that's times 5, and then times 12, which is the height. So let's just times all these things together. So a third, remember first we just do it, which is 1 divided by 3. Press equals and then times 3.14 times 5 times 5 times 12. Okay, so here we go. That equals 314. Okay, and that is centimetres cubed. Right, question 3. A soft drink comes in a cylindrical can. If the can has a radius of 4 centimetres and a height of 15 centimetres, what is the volume of soft drink? Okay, right, so we've got 3.14 times the radius squared, so that's times 4, times the height, which is 15. Okay, and we can times all these together. So okay, there we go. And they want it to, well, I'll write this here first, and they want it to the nearest whole number. So we'll say that that is 754 mil, which is also centimetres cubed. You can use them interchangeably because a milliliter is 1 centimetre cubed. Josh is playing with a bouncy ball, which is in the shape of a sphere. If the radius of the ball is 7 centimetres, what is the volume of the ball? Okay, right, that's going to be a massive bouncy ball. So what we've got here, we've got 4 over 3 times 3.14 times the radius, which is 7, cubed, which is 7 times 7 times 7. Okay, so here we go. Let's do this. So first of all, the fraction, 4 divided by 3, press equals, times 3.14, and then times that by 7, times 7 times 7. Okay, so there we go. That's going to be 1436.02, which to the nearest whole number is going to be 131436 centimeters cubed. Okay, right. Question 5. Okay. A prism-shaped pencil holder has a triangular base and an area, it must be on its side, and an area of 16 centimeters squared. A prism-shaped pencil holder has a triangular base with an area of 16 centimeters squared and a height of 10 centimeters. What is the volume of the pencil holder? So the volume of triangular prism equals triangle area times height. So the triangle area is that's not right. I've got several things I don't like about that. Equals triangle. Equals triangular area times height, and then format this. Arrange. No, that doesn't work. No, they've only got the triangular prism on its bottom. Okay, that's fine. Okay, triangular area. Okay, so here we go. The triangular area is 16. The height is 10. So 16 times 10 is 160 centimeters cubed. Here we go. Right. Question 6 says, Anna has a small cube-shaped jewellery box. If each side of the box measures 5 centimeters, what is the volume of the box? So that's going to be 5 times 5 times 5, which is going to be 125 centimeters cubed. Oh, I've gone too far. I meant to mark the first 5 first. So let's go back and do that. Okay. Here we go. Right, so what have we got here? We've got the first one is 72,000 centimeters cubed and 72 litres. There we go. Get a mark for both of those. Right, this next one we've got 314. Yep. Perfect. Next one we've got we haven't obeyed our own rules of rounding to the nearest. Oh no, right, this one suddenly says round. I should have checked up here. Round answers to 2 decimal places. I haven't been doing that. I've just been going to the nearest whole number. So 1 second, let me delete that. 753.6, so I can do that. 753.6 mil. There we go. Or centimeters cubed. Right, there is a bracket missing there anyway. So what page? That is slide 364. Okay, let's go all the way to 364. Okay. Put in that bracket there. Okay, and then let's get that back up. Get this back up. Fine, so that is now correct. So I didn't necessarily round that one correctly. Oh, here we go. That's convenient. 026. So that means that is 1436.3. Okay. And that is correct. And here we go. This one is 160 centimeters cubed. Yep, and that's right there. And well, as we've done number 6, we might as well mark it. 125 centimeters cubed. Perfect. Right. Okay, let's move on to question 7. And then we can make this large, and then we can answer these. Okay, here we go. So, a pyramid-shaped tea bag holder has a square base with an area of 9 centimeters squared and a height of 6 centimeters. What is the volume of the tea bag holder? Okay, so it's a third times the base area, which is 9, times the height, which is 6. Okay, here we go. So let's work this out. Well, I can do this without a calculator actually. A third of 9 is 3. 3 times 6 is 18. So that'll be 18 centimeters cubed. Okay, next one here. We have got a candy mold creates half sphere shaped chocolate. If the radius of the mold is 2 centimeters, what is the volume of one chocolate? So the volume of a hemisphere is 2/3 times pi times radius cubed. So that's 2 over 3 times 3.14 times 2 times 2 times 2. Okay, let's do this on the calculator. So 2 divided by 3 equals 0.666 times the 3.14 times 2 times 2 times 2. Okay, and so there we go. This is going to be 16.746. And remember, it's 2 decimal places this time. So this is 16.75 centimeters cubed as the answer. Right. Next one here, we've got 47. And this says, Tay is building a box. He needs the volume of the box to be 2,400 centimeters. He also needs the width to be 20 centimeters and the length to be 40 centimeters. How high does he need to make the box? Okay, right. So we have got the volume of the box. So we've got the length. We need the length is 40 times a width of 20 times the height. We don't know the height. And that equals 2,400. Okay, so 40 times 20 is 800. So 800 times the height equals 2,400. Okay, to find out what the height is, we're going to just do 2,400 divided by 800, and that will equal 3. So we know that 800 times 3 will give us 2,400. So the height equals 3 centimeters. And remember, the height is a length, so we'll leave it like that. Okay. Right, question 10. So it says here that Gordon is making a cake and has made 40,000 centimeters cubed of batter. He has a tin that is 8 centimeters by 20 centimeters by 5 centimeters. How many times can he fill the cake tin? Okay, right, so let's have a look. So the volume is length times width times height. So we've got 8 times 20 times 5. So 8 times 20 times 5, what, 5, that's going to be 800. So the tin takes 800 centimeters cubed, okay? And we want to know how many, so we know that one tin equals 800 centimeters cubed. We want to get up to 4,000 centimeters cubed. Okay, so what are we going to times that by? So if we do 4,000 divided by 800, that equals times 5. So it's 5 tins. 5 tins or 5 times. Okay, right, let's get these ones marked. Okay, so here we go. Right. Question 7. Scenario. Here we go. Yeah, 18 cubic centimeters, but that then says meters cubed there. It was meant to be cubic centimeters. (18 cubic centimeters). Okay, that was right though. Next we've got 16.75 centimeters cubed. Oh, and then it says millimeters cubed there. Oh gosh, this one's gone. Okay, here we go. Question 9. We've got 3 centimeters. Yeah. And question 10. 5 times 5 tins. Yeah. Perfect. Right. Okay, question 28. More shape. Right, so here we go. Yeah, I'll do this round. I'm going to have to stop at 48 today, because I'm going to run out of time. So we've done 46, 47, and if we get 48 done, that would be really good. Okay, find the volume of the triangular prism if the base of the triangle is 6 centimeters, the height is 5 centimeters, and the length of the prism is 10 centimeters. Okay, so area of a triangle is base times height divided by 2, or half base times height. So the triangle, okay, the triangle would be half times 6 times 5. And then to find out the volume of the prism, you just times it by the length. So here we go. So half 6 is 3. 3 times 5 is 15. So we're looking at 15 times 10. And that's going to be 150 centimeters cubed. Okay. Next, find the volume of the triangle prism if the base of the triangle is 10 centimeters, the height is 2 centimeters, and the length of the prism is 6 centimeters. So again, we find the height of the area of the triangle, multiply it by the length of the prism. So we've got a half times 10 times 2, and then that's the area of the triangle, and then we times that by 6 to get the volume of the prism. So half of 10 is 5, 5 times 2 is 10, 10 times 6 is 60. So this will be 60 centimeters cubed. Next one. Okay, find the volume of a triangular prism if the base of the triangle is 4 centimeters, the height is 5 centimeters, and the height of the prism, okay. If the base of the triangle is 4 centimeters, the height is 5 centimeters, and the height, yeah, that's fine. It's clear what that's talking about. So that's going to be 4 times half times 4 times 5 for the triangle, and then times the 8 for that. So half of 4 is 2, 2 times 5 is 10, 10 times 8 is 80. So that would be 80 centimeters cubed. Okay, question 4. Find the volume of the triangular prism if the base of the triangle is 15 centimeters, the height is 4 centimeters, and the height of the prism is 2 centimeters. Okay, so here we go. So half times 15 times 4 for the area of the triangle, and then times 2 to get the volume of the prism. So I'm going to do a half of 4 actually. A half of 4 is 2. 2 times 15 is 30. 30 times 2 equals 60 centimetres cubed. Okay. Question 5. Find the volume of the triangular prism if the base of the triangle is 4 centimetres, the height is 4 centimetres, and the length of the prism is 6 centimetres. Okay, right, so here we go. Let's have a look at this. We've got half times the base, which is 4, times the height, which is 4, and then times the length of the prism, which is 6. A half of 4 is 2, 2 times 4 is 8, 8 times 6 equals 48 centimetres cubed. Okay, that was a nice quick one. Let's go to the mark scheme and see if these questions were right. Okay, here we are, 48, find the volume of a triangular prism practice. So 150, yeah, that's good. 60, yeah, that's good as well. 80, yeah, that's good too. 60 centimetres cubed, yeah, that's great. And then 48 centimetres, okay, great. Oh, what a nice collection of correct answers with no editing. Okay, right, so here we go, question 6. So here we go, it says the volume of a triangular prism is, it's a volume, they've given us the volume already. The volume is 100 centimetres cubed. If the area of the triangle is 20 centimetres squared, what is the length of the prism? So the volume of a prism, volume equals the area of the triangle, area of face, times length, okay? So this is for any prism here, volume prism. Okay, so what we need to do is we just need to plug this in and work backwards. So the volume of the prism is 100, and that equals the area of the face, which is 20, times the length. Okay, so we know that 20 times something equals 100. Well, I actually know that if we do 100 divided by 20, that equals 5, and so therefore 20 times 5 is 100, so the length must equal 5 centimetres. Okay, right, question 7. So here we go, we've been given the volume again, so we know that 200 is equal to the area of the face times the height. So the area of the triangle is 100. So 100 times the height. Well, I can spot here that I know that 200 is 100 times 2. So the height must equal 2 centimetres in this scenario here. Question 8, it says the volume of a triangular prism is 50 centimetres cubed. If the area of the triangle is 10 centimetres squared, what is the length of the prism? Again, so volume is equal to the area of the triangle times the length. Okay, so in this case, 50 equals 10 times the length. Okay, well, I know that 10 times 5 gives us 50, which could also be found by 50 divided by 10. So the length in this case must be 5 centimetres. Okay, right, question 9. Here we go, we've got the volume of the triangular prism is 81 centimetres cubed. If the area of the triangle is 9 centimetres squared, what is the height of the prism? So remember, 81 is going to equal the area of the triangle times the height. Okay, well, I know that 81 is 9 times 9, so the height must be 9 centimetres, just 9 centimetres, not 9 centimetres squared, because the height is a length. Here we go. And lastly, question 10. And this one says, the volume of a triangular prism is 1,200 centimetres cubed. If the area of the triangle is 30 centimetres squared, what is the height of the prism? So again, so we know that 1,200 equals the area of the triangle, which is 30, times the height. Okay, so we've got 1,200 equals 30 times something. I'm just going to do 1,200 divided by 30 to find out what that is. Okay, 1,200 divided by 30, and that equals 40. So the height will be 40 centimeters. Okay, right, let's get this round marked. So, question 6. So we've got here 5 centimeters, and then we've got here 2 centimeters, and then we've got down here, we've got 5 centimeters. Yeah, that's right. Question 8 is 5 centimeters. Then we've got 9 centimeters. Yep. And then we've got 40 centimeters. Excellent. Right. So I'm going to make this set the last one now, these scenario questions, and then we will have to finish here for the evening. I've ruined my track of doing 5 in a row. Never mind though. It will sort itself out in the future. Right. Question 1. Anna's fish tank is in the shape of a triangular prism and has a volume of 100 litres. If the tank is 2 metres long, what is the area of the triangular base? What a funny fish tank. Okay, right. Oh, well, it's not this way round, is it? It's going to be on its end. Right, so here we go. What we've got here is the volume is 100. So that equals the area of the face times length. Okay, so, oh, this is tricky. Oh, there's loads of things to consider. Right, so scenario questions. 1 litre equals 1,000 centimetres cubed. 1 centimetre cubed equals 1 millilitre. Okay, right. So what we have here is 100 litres, and this is in metres. Right, so we need to get our units in order. So 100 litres. Well, if 1 litre equals 1,000 centimetres cubed, then 100 litres equals 100,000 centimetres cubed. Okay. Now, we need to get this into centimetres because this is 2 metres. So if 1 metre, they haven't told us this, but we need to know it, equals 100 centimetres, 2 metres equals 200 centimetres. Okay, so let me get rid of this here. So we know that 100,000 is equal to the area times 200. Okay, so this is the volume, this one here. This is the length. And then what we just need to do is we just need to rearrange this. So we can do 100,000 divided by 200, and that will give us the area of the triangular base. Okay, right. So 100,000, another 0, divided by 200, and that's going to be 500 centimetres squared. Right, okay, so I am actually just going to, I need to just work out what page this is because I need to edit that slightly. 219, because this is on a different line to the litres. I don't like that. And I saw that I had an upright fish tank. So I'd prefer that. Cylinders. 219. Here we go. And here's that upright fish tank. What's going on there? Can I not send it back? There we go. perfect. There we go. Right, so that's that one done. Where else did I want the upright fish tank to be? It wasn't here. Yeah. It was here, wasn't it? Yeah, a pencil shot. That doesn't make sense. There we go. Yeah, that's fine. That should say length. Right. That should say length. Right. So there we go. So that's all sorted there. Sorry, I'll be back in a second. Okay, right, here we go. We've got this one here. Quinn is building a swimming pool with a triangular prism shape. The pool has a volume of 500 cubic meters. She wants it to be 5 meters wide. What is the area of the triangular cross section of the pool? Okay, so this is all in meters. That's fine. Great. So this is the width. So that's the bit that's 5 meters wide. So we've got volume is 500, and that equals area times length. So 500 equals the area times the 5. So the area equals 100 meters squared. Okay, right, here we go. David is packing socks into a triangular prism-shaped net to hang in his wardrobe. The net has a height of 120 centimeters. If it has a volume of 6,000 cubic centimeters, what must the area of the triangular base be? Okay, so we've got 6,000 equals, these are all centimetres, which is lovely, so we can just keep going, equals the area times the 120. Okay, so if we do 6,000 divided by 120, we will get the area in centimetres squared. So let's do that. So 6,000 divide the 120 equals 50. So that'll be 50 centimetres squared for the area. Right, question 4. We've got here, Lisa is planning to pour a concrete slab for a patio in the shape of a triangular prism. If the area of the slab 1. I missed out the word is. Okay. If the area of the slab is, and that's actually, I need to press enter there, because is 1.5 square meters, and the depth is 10. Oh, why am I doing this? Square meters, meters squared. Right, where have I got the unit? Here we go. 1 second. I need a meters squared. This one will do. Okay, that's done. Doesn't make sense to mix these up. Right, here we go. Lisa is planning to pour concrete slab Lisa is planning to pour a concrete slab for a patio in the shape of a triangular prism. If the area of the slab is 1.5 meters squared and the depth is 10 centimeters, what is the volume of the concrete? Okay, right, so that's fixed. I think I might have to do this section again just to double check what all these changes that I've made. Right, so let's go through back to here. So here we go. We know that the area of the slab is 1.5 square meters. The depth is 10 centimeters. Okay, what is the volume? Okay, we've got to pick a unit. We can either do meters or centimeters. Because the area is in square meters, it's a bit messy. So I'm going to go with meters. So 10 centimeters equals 0.1 meters. So it's much easier to work in meters with this one. So what I'm going to do is we're going to have the volume will be 1.5 times 0.1, okay, and that's going to be 0.15 meters cubed. Okay, right, next one here. We've got question 5, and it says, Mark bought a fish tank. See, this is what the fish tank was always meant to look like. Mark has bought a fish tank in the shape of a triangular prism. For the number of fish he has, he needs to fill it with 80 litres. Okay, they're not on the same line. 1 second. For the number of fish he has, he needs to fill it with 80 litres. Oh, I've done with. Right. Mark has bought a fish tank in the shape of a triangular prism. For the number of fish he has, he needs to fill the tank with 80 litres of water. Given the base of the tank has an area of 320 centimetres squared, and if the this does not make sense. Right. And given that the base of the tank has an area of 320 centimetres squared and the tank has a height of 1.5 meters, okay, let's keep... Okay, is the tank large enough? Is the tank large enough to hold his fish? Okay, here we go. So Mark has bought a fish tank in the shape of a triangular prism. For the number of fish he has, he needs to fill the tank with 80 litres of water. Given that the base of the tank has an area of 320 centimetres squared and the tank has a height of 1.5 metres, is the tank large enough to hold his fish? Okay, right. Let's answer this question. So I'll just put a star here to say that that's been formatted. Okay, so what we've got here is we're going to fill this out. So 80 litres, 1 litre equals 1,000 centimetres cubed. Okay, 80 litres will be 80,000 centimetres cubed. The base of the tank has an area of so I need to change this into centimetres. So we'll say the height is 1 metre equals 100 centimetres. So 1.5 metres equals 150 centimetres. Okay, so then from there what we have is, that's 150 centimetres. So we know that the volume is 80,000 and that equals the base 320. Well, no, we need to find out. So basically we need to find out the volume, don't we? So the volume, so the area, 320, times the height, 150, has to equal less than 80,000 for the fish tank to work. Okay, so let's try this. So 320 times 150, and that equals 48,000. So no, not enough space for the fish. Okay, right, let's mark these. Okay, so here we go. I need to get the answers. And then here we go. Right, so we're at the volume of a triangular prism scenario. So area, excellent. We agree with that one, so that's correct now. Yep, meters squared, square meters, yep, that's fine. 50 centimeters squared, yep. 0.15 meters, perfect. Oh. And then, no, the volume of the tank is only 48 litres. Yep, excellent. So we got that information there. We put this down, but because we'd done this conversion, that's fine. So this was just another way of writing the same thing. Okay, right, last 5 for today. Right, so here we go. So we've got here, Olivia is constructing an ice sculpture in the shape of a triangular prism. She wants the sculpture to have a volume of 500 cubic centimetres, with the triangle having a height of 10 centimetres and a base of 10 centimetres. How long should she make the prism? Okay, right. So we've been given the details to find out the area of the triangle. So the area of the triangle is a half times 10 times 10, which will be 50 centimeters squared. Okay, so that's the area of triangle. Okay, then we need the volume to be 500. So we've got to have 50 times the length has to equal 500. These are all centimeters, so that's all fine. So the length has to be 10 as well. Okay, that would be somewhat of an underwhelming ice sculpture, but that is fine. I don't have an ice sculpture, so I can't say anything. Here we go. Sorry about that. Okay, right, next one. So here we go. Jack is making homemade candles using a mould in the shape of a triangular prism. He wants each candle to have a volume of 300 ml. If the triangle has a base of 5 centimeters and a height of 6 centimeters, what should the height of the candle be? Okay, so the area of the triangle is a half times the 5 times the 6, which is going to give us half of 6 is 3. 3 times 5 is 15. Okay, he wants it to have a volume of 300 ml. So remember, 300 ml equals 300 centimeters cubed. Okay, so we've got that there, 300 centimeters cubed. What should the height of each candle be? So this is the volume, this is the area. So we want 15 times the height to equal 300. So we need to do 300 divided by 15, which I believe is 20, but let's double check. 300 divided by 15 is 20. There we go. So the height should equal 20 centimeters. Okay, right. Question 8. Sophia is building the casing for a concrete ramp. The triangular cross section has a height of 20 centimeters and a length of 2 meters. Okay, so this bit's 20 centimeters. this bit is I should say base there, because that's the word that we use for the length of a triangle. And base of 2 meters. If the depth of the prism is 1.5 meters, how many liters of concrete does she need to order? Okay, right, so just to say we've done that, so this has changed to base. Okay, so we need to change all of this into centimeters. So we've got the 2 meters equals 200 centimeters, 1.5 meters equals 150 centimeters, just because we know the conversion from centimeter cubed to liters, okay? And they want to know how many liters of concrete we need. So we need to do 20, a half, times 20 times 200. Okay, so that's going to be 10 times 200, so that's going to be 2,000 centimeters squared. And then we need to times that by the 150. Okay, and that will give us the volume in centimeters cubed. So 2,000 times 150 is 300,000. Okay, and then every 1,000 centimeters cubed is a litre, so this equals 300 litres. Okay, so it's 300,000, so 300 lots of 1,000, every 1,000 is a litre, so this will be 300 litres. Right, okay. Question 9. Michael is building a birdhouse in the shape of a triangular prism. The birdhouse has a volume of 150 cubic inches and a height of 5 inches. What is the area of the triangular base? Okay, so area times the height, which is 5, will equal 150. Okay, well, I know that 30 times 5 equals 150. So the base will have to be 30 square inches. Okay, and lastly, question 10. And it says, Rebecca is making triangular tiles. She has a block of clay with length 10 centimeters, width 20 centimeters, and depth 10 centimeters. Okay, her tile design takes a shape of a triangular prism of depth 2 centimeters and a triangular cross section with base 5 centimeters and height 4 centimeters. How many tiles can she make? So first of all, the first bit that we need to know is what the volume of this block is. So it's got length, width, depth. It's a cuboid. Okay, so we're going to do the volume of that first. So the volume of block is going to equal 10 times 20 times 10, which is 100 times 20, which is going to be 2,000. So that's the volume of the block. Okay, and then the volume of the tile design is going to be the area of the triangular cross section, which is a half times the base times the height. Okay, and then we're going to have to times that by the depth. Okay, so a half times 4 is 2, 2 times 5 is 10. So the area of the block of the triangle is 10 centimeters squared. And then if we times that by 2, we get 20 centimeters cubed. So 20 centimeters cubed per tile. Per tile. And then, so how many do we get? If we've got 2,000 centimeters cubed. So if we do 2,000 divided by 20, that leaves us with 100 tiles that she can make. Okay, right, let's get this marked and we will call it a day there. Okay, well done everyone for sticking with me. That's absolutely brilliant. Thank you so much. And I'm sorry for all the changes that I've made, but it has been worth it, okay, to make sure that the book is going to be in top-notch condition. Okay. So, let's mark these. So we have got question 6 will be 10 centimeters. Excellent. Question 7 is 20 centimetres. Question 8 is 300 litres. Yeah. 30 square inches. And 100 tiles. Perfect. Wonderful. Right, well, thank you so much for sticking with me, and thank you so much for all of that. I will hopefully see you tomorrow morning, actually, for another continuation starting at topic 49. Okay, perfect. Thank you very much. See you soon. Bye.